Before I go over the lesson, let's go over some of the vocabulary terms that I will be using. So this symbol right here, we call that radicals, right? And let's just say x to the fifth here, we call that radicand. That's a radicand. And let's just say you have a root right here. Okay, that numbers right there we call root or indexes, okay? So if you don't see a root right here, we always assume that's invisible too, okay? Keep that in mind. So let's look at these problems right here. If I want to simplify the root of x to the fifth, that's how you would say it, is to go, first we're going to break the x to the fifth down in terms of third roots like this. See that? So remember the exponents property, product property, 3 plus 2 is 5. Okay, so that's how I break it down. So right here you see this part right here match. That means that base x gets to go out. And the one that doesn't match, it's stuck inside the radical because it doesn't have enough power to get out. Think of it as that way. Okay, so right here, this gets to go out, so x gets to go out, and then the x squared is stuck behind. So this right here is simplified. Okay, so this would be like a simple case to look at. Now let's move on to the case where it's a bit more complicated. Let's look at number 1. Okay, number 1, notice I don't have a root here. That means we assume there's invisible 2, okay? So let's break down 32 all the way. So that's going to be 8 times 4, 3, sorry, not 3, it's 4 times 2, this is 2 times 2, and then this is 2 times 2. So 32 is 1, 2, 3, 4, 5, 2 to the 5th power, okay? So 2 to the 5th power, and then we have n to the 6th. Now I'm going to break all of these exponents in terms of 2's because we're working with square roots, okay? So 2 square, and 2 to the 1st. And then n2, n2, n2. So let's highlight the one that has enough power to get out. This one right here, and then the one that I'm not highlighting, it stuck behind because it doesn't have enough power to get out, okay? Because we're working with squares, and this one in green right here is only 2 to the 1st power. That's not enough, so it's stuck behind. So we have this get out right here, 2 2's. We have 1, 2, 3 n's get out, and then we have 2 to the 1st stuck inside. So 2 times 2 is 4, and that's going to be n to the 3rd power, and then we have a 2. This right here is our final answers, okay? Same thing with number 2, except we're working with third root, okay? So keep in mind, we have to break everything in terms of 3rd power, okay? So 16, if you break 16 down all the way in terms of 2's, you have 2 to the 4th power. And then n is going to be n3, 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 and n1. So here we have 2 square, no, not square, we're not working with square. It's be 2 to the 3rd, 2 to the 1st, and 3rd, and 3rd, and 3rd, and n to the 1st. Okay, let's highlight the one that gets to go out. In this case, it's this 2 right here, this n, okay? And the one I'm not highlighting, those are the ones that stuck behind, okay? So this 2 gets to go out, these 3 n's, and the one that does not have enough power, this one right here, stuck behind. So our final answer is 2, n to the 3rd power, because we have 3n here, the root of 2n. And this right here is our final answers. Okay, let's move on to number 3. Okay, in number 3, let's break down 243, okay? It's going to be 81 times 3. This is 9 times 9. 3 times 3. 3 times 3. So 243 is 1, 2, 3, 4, 5. 3 to the 5th power, okay? So 3 to the 5th power, x to the 8th, y to the 9th, z to the 7th. So now we're working with root 4, meaning we're going to break everything inside. All the radicand needs to be to the 4th power if there is enough power, okay? So 3 to the 5th could be 3 to the 4th, 3 to the 1st, x to the 4th, x to the 4th, y to the 4th, y to the 4th, and y. And then we have z to the 4th and z to the 3rd. Okay, I'm going to highlight the one that can get out. This one can get out, this one can get out, this one can get out, okay? And then the one that's not getting out, let's highlight in green, okay? So those ones are not getting out because it doesn't have enough power, okay? So I already have a 2 in front, copy it down. So 1, 3 gets to go out, 2x gets to go out, 2y gets to go out, 1z gets to go out, and the rest stuck behind. Don't forget the root. Keep on forgetting that. So we have 3, y, z to the 3rd. Okay. So in front we have 2 times 3 is 6. X and x is x squared. That's going to be y squared. And that's going to be z. And then we have 4th root, 3y, z to the 3rd. Right there, that is your final answers. Okay, let's move on to number 4. Okay, number 4, notice we have a negative base, okay? So for now, let's break down that negative 27. So negative 27, we have a negative 9 and a positive 3, or we have a negative 3 and a 3, okay? But so we have a negative 3 times 3 and 3. That's negative 27. Or we have another choice of making all of these a negative. You guys see that? This is negative 27, and this is also negative 27. Oopsie. But I wouldn't pick the first option because that's going to help us simplify using the 3rd root, right? So I would pick these options right here where I can rewrite it as negative 3 to the 3rd power. See that? So this first option right here, although it's also correct, but it wouldn't help us simplify the problem. So we're not going to use the first option. We'll use the second one, okay? So x to the 5th is x to the 3rd times x squares. And y14 is y 3rd, y 3rd, y 3rd, y 3rd, and y squares. So 6 is already out. This right here, the negative 3 gets to go out. Let's highlight the one that gets to go out. Okay. And then how many y's? 1x gets to go out, and then we have 4y gets to go out. And then whatever's that I didn't highlight, those are the ones stuck behind, which is x squared, y squared, okay? So in front, 6 times negative 3, that's negative 18. X, y to the 4th, 3rd root of x squared, y squared. It's important that you write the root between the radical symbols because I have students that write it as if it's a regular exponents outside, and that would be the wrong way of writing it, okay? So this is your final answer right here.